What are we likely to do when we're logged into a chassis? Well, we're going to need to configure it. We're going to need to validate our configuration. And we also want the ability to take a look at what's going on. And the general way we look at the present status of a chassis is kind of like a snapshot, is we use what are called show commands. And this is the first show command that we've really seen. Show. There are other validation commands like debugging. That's real-time events. This isn't that. I do it, it gives me output, and it doesn't change unless I rerun the command. Maybe I rerun the command with an up arrow and press enter. So show version. Well, this is about the chassis and the operating system that it runs on it, specifically the operating system version. This is a core command on both routers and switches. And yes, we're looking at it on a switch. We do this command and we see major information about the chassis. First, what kind of switch is it? Think, of course I know what kind of switch. Well, what if you have hundreds of switches and you add a telnet to a switch, secure shell to a switch, and you're not sure what kind of switch it is because all you did is you put in an IP address. Show version. Okay. It's Catalyst 2960. C for Catalyst. I could see the operating system version. Operating system versions come a long way in a very short amount of time. Used to deal with 12.0, 12.1, 12.2 for switches. It's not what we see here. See 15.0. And 15.0 is recent, within the last few years. We can see other elements like how long it's been on. So if Raymond reloaded the chassis, that's going to go down to just a few minutes of being online. We can see the file that was loaded, and the file has a long decode if we need it. The decode is the exact operating system to the version, to the feature set, but you're always going to see something pretty consistent at the end of it. Raymond, what's the extension for the file for an operating system?
That would be .bin.
Binary. Same is true for a router. So .bin for routers also. You can see things that we don't really care about. I don't actually care too much about memory on a switch. I care about it more on a router because routing tables consume memory. If I'm running the internet routing table, I start to really worry about that. You could see things like your underlying hardware and processor, but we don't care about that too much on a switch because so many of the tasks are done in hardware. Hardware called ASICs, application-specific integrated circuits. So I don't usually care about the memory or the CPU of a switch chassis. I just don't.
Interfaces are going to connect our end stations up to the network. Some interfaces are going to be used as uplinks to other switches or routers. And looking at the output of the show interfaces command for that specific interfaces is going to be a big deal. We're looking at fast Ethernet 0/1 here. It's up, up. Ooh, up, up. Damn, when I hear up, up, that means things are pretty good, aren't they?
Well, when I hear that at home, it probably means I overslept. But here, it speaks to us about different layers of the OSI model. Wait a minute. We get to talk OSI model on an interface page? Raymond, if we're going to simplify this as we do in Cisco, simplifying layer 1 and layer 2 here, which one speaks to us about layer 1? Which one speaks to us about layer 2?
Very first up we see is about layer 1. So fast Ethernet 0/1 is up, is referring to the physical layer. Layer 1. Line protocol is up. That's referring to layer 2. So if we're up, up, that means we're up at layer 1 and we're up at layer 2.
Raymond, I saw a command that you issued before called no shutdown. So that goes to what Raymond was talking about, where we have the removal argument of no, followed by shutdown. Let's actually reverse that and say shutdown. I type in shutdown. Raymond, what would I expect to see from this output if the interface were in possession of the shutdown command?
Well, at layer 1, we'd no longer be up. We would actually see administratively down, because we shut off that port. And then at layer 2, since we're down at layer 1, we'll be down at layer 2. So we'd see administratively down here in our output. Now, Dan, something stands out here to me. The thing that says BIA. BIA stands for burned in address. Earlier when we were looking at the OSI model, we talked about addressing at layer 3. We talked about addressing at layer 2. We distinctively said layer 3 addressing was IP addresses. Dan, that doesn't look like an IP address to me. What is that?
It's a layer 2 address, folks. That is a layer 2 address, and there's some characteristics that really scream MAC address or BIA. We usually call it MAC address. We got some hexadecimal in there. IP version 4 addresses are not written with hexadecimal. They're written with dotted decimal. Secondly, it's the wrong number of digits. MAC addresses are 48 bits long, and a hexadecimal digit is 4 bits. It represents 4 bits. So we have 12 digits, each representing 4 bits. So 12 times 4. What is 12 times 4? Just pause. I don't want to give it to you. 12 times 4. 48. It's a 48-bit address. IP addresses are 32 bits. So it's wrong in so many ways. But it is an address. Don't get confused by this, though. Here's where we're going to get some challenges. Raymond, are end-user PCs going to be communicating to the MAC address of the switch when they want to send through the switch?
If I'm sending through the switch, I don't care about the switch. All I want the switch to do is its job. So I don't care about the switch's MAC address. I care about my MAC address and in the MAC address of the destination. So it might be another PC inside of my local area network, or it might be the MAC address of my default gateway.
So the only time I'm going to communicate to this MAC address is if I am managing it. If I'm managing it, then I'm talking to the switch and not through it. But that's the exception and not the norm. You can see some other elements here. You can see the duplex. Full duplex means send and receive both simultaneously. I can see the operational speed. This is a fast Ethernet port. So Raymond, what's the maximum speed that this port is capable of?
Fast Ethernet would be 100 megabits per second. Now you said something important. You said capable of. Because we could lower the speed of the port. We can never make the port be faster than it can actually be. So 100 megabits per second, that's our max. But we could lower it down to 10 megabits per second if we had to.
So there's some great diagnostics that we can get from this, and revisit the command that gave us the information. This command, the way that I think of it, is give me layer 1 and layer 2 information about the port. And that really is the best way to think about it. You're thinking in terms of the OSI model and verification output that pertains to the OSI model. There are other commands that might look at layer 3 information about the chassis. And so having that foundation of OSI model is important to us, again, when we least expect it.
Let's go back to our running config and let's verify what we've configured. We've done basic switch configuration. What did we do? We changed our host name. We can see that here in the output of our show running config. Host name, switch X. What's the default value? It's just switch. We configured interface VLAN 1 with an IP address. What was that IP address for? It was for management purposes. So that way there I could telnet to and from the switch. I could ping to and from the switch. It's management purposes. We also set up a default gateway. We can see that IP default gateway. And then the IP address of that router. That is the exit point of our local area network. So as we said before, that running config is going to show us everything that is currently running on this switch. So Dan, if we left here and we didn't copy this running config to startup config, and while we were gone, the switch lost power, what would happen when we came back?
Okay. Well, I'd no longer be able to manage the switch because it would have lost the management parameters. It would have lost the IP address subnet mask default gateway. And so far, we'd still have connectivity through the switch. Here's the reason why. It's because we aren't doing anything more advanced like VLANs. If we had gone out and configured VLANs, essentially partitioning our switched environment into multiple broadcast domains, well, that configuration would have been lost also. And then, guaranteed, you would have a massive disruption of connectivity. But out of the box, if you only intend for everyone to live in the same broadcast domain that happens to be on this switch, and you don't have a complex switch infrastructure that requires things we'll see, like trunking to and from switches, supporting multiple VLANs, and the moment you have that, and you haven't copied your running config to your startup config, connectivity is lost, your configuration, because it's gone, and the configuration was providing the connectivity you needed, you're going to have to start over and also probably explain the prolonged disruption of service in the LAN.
So let's not forget, copy running config, startup config. It's a fundamental command that we have to do every time we make a change. Show version is a great command that we can utilize to verify the actual software as well as hardware that we have configured on our actual Catalyst switch. Scroll back up to the top here of this output, and let's take a look at some of the different things it's telling us about. We can see here that the Cisco iOS software for this Catalyst 2960 switch is the actual C2960 LAN-based K9-M image, version 15.02 SE. If we need any technical support, we can go to this website here, cisco.com, tech support. Some copyright information. And then it shows here in ROM we have a bootstrap program. This bootstrap program is actually utilized to find where the iOS image is, find where our configuration file is, and then get those loaded so that way there the switch can actually function as it's intended to with the actual operating system running and the configuration file that we had saved. We can see our uptime for the actual switch. We can see where our actual iOS image is stored. In this case, it's stored in Flash. And this is the actual name of the iOS image with the .bin extension at the end. Product, where we are actually using it or intending to use it. So just make sure you check with the laws and regulations in regards to the cryptographic features on the device before you start bringing it all over the world. But down here we can start verifying our processor. We have a PowerPC 405 in this particular switch, and we can actually see how much memory is in the switch as well. The actual processor board or motherboard, its ID.
how many virtual interfaces we have, physical interfaces we have. Our base Ethernet MAC address. Our model number. And then down here, just a brief summary of some of the important things. Number of ports, the model number, the software version we're actually running, and then the actual name of the software image.